element and periodicity in properties. So, have you looked into your textbook back page? There will be a table. Have you seen this? This is called a periodic table. So, I'll explain this table in detail. Um, so, periodic table consists of 18 columns and 7 rows. Okay. 7 rows. Hydrogen will be placed on top of the periodic table if you notice properly, and helium will be, and all the noble gases will be at the end. So how many so there are 18 columns, so there are 18 columns and 7 rows. There are 7 rows. So if you notice the first element, hydrogen, and you can notice helium. So first period consists of 2 elements. Then after hydrogen, so this thing increases. It becomes 8 and it gets doubled here. It becomes 18. Then it becomes here also 18, and when you go down a group, so elements increase. So second period will be like 8. This is not a perfect, so refer the periodic table, 8 elements. Then third will be like 8 elements. Fourth period will have 18 elements. Sixth period will have 32 elements. Seventh period 30 elements. So when you notice the periodic table, they will increase in descending order. So now what I have to notice properly is the first column we see in a periodic table is called alkali metal. Alkali metal. So the second which you see is called alkaline earth metal. Alkaline earth metal. So this is called alkali metal and this is called alkaline earth metal. So now if you look at hydrogen, hydrogen has a special property, because when hydrogen attains an electron, it becomes a noble gas, and if hydrogen loses electron, it becomes alkali metal. So hydrogen, nowadays hydrogen is placed at middle or somewhere at the top of the periodic table because we can't specify hydrogen. So now when you look at the syllabus, if you look at the portions or for supplementary, they will ask you like what is Mendeleev periodic table and modern periodic table. They won't ask you like law of octaves, but you have to understand everything. So I'll teach you everything. Now the first scientist to arrange elements in periodic table was none other than Dobrinier. So Dobrinier was the first scientist to arrange elements in periodic table, but his law was not accepted because element showed various properties, so we can't accept this guy's laws. So he proposed law of trades. So what is this law of trades? If you see is the atomic mass of middle element of a trade is nearly equal to arithmetic mean of other two elements. So what this guy did is atomic mass of middle element. Now see, now there are three elements A, B and C. A, B and C. So this atomic mass of the middle element present here will be equal to arithmetic mean. So that is B equals A plus C divided by 2. So B will be nearly equal to arithmetic mean of these two elements. Example, if B weights, if A has 7 and B has 39 divided by 2, so we get 46 divided by 2 is equal to 23. So the mean weight of B will be 23. So A will be 7, B will be 23 and C will be 39. So he proposed a law like this. So they didn't accept because various elements showed various properties. You can't measure like this. So second scientist who discovered thing was Newland. What Newland did is every eighth element. So he proposed a law. He proposed law of octaves. Law of octave. So he said that every eighth element is similar to first element when placed in increasing order of the atomic weight. So this guy proposed, Newland proposed law of octaves. He said that every eighth element, so every eighth element, 1, 2, 3, 4, 5, 6, 7, 8. So every eighth element will be equal to the first element and placed in increasing order of the atomic weight. But this law also could not satisfy because other element weighted more than what he expected. So now finally Mendeleev proposed a law called periodic law. So this law could satisfy some of the elements, but it cannot satisfy everything because new elements have to be discovered. And so what law he proposed is periodic law. So what is periodic law? The properties of the element are the periodic function of the atomic weight. So Mendeleev law is all about atomic weight. So years after, Henry Moseley, a scientist named Henry Moseley, showed a plot against plot against atomic number, because atomic number was had more fundamental properties than atomic weight. So he considered atomic number as periodic property. So after he discovered the atomic number, is more fundamental. He stated this modern periodic table. So what is this modern periodic table? The properties of element are the periodic function of their atomic number. So modern periodic table consists of atomic number but not atomic weight. That's the only difference between Mendeleev and modern periodic table. See, Mendeleev said that properties of element are the periodic function of their atomic weight. But modern periodic table states that atomic weight is more fundamental than atomic number. Atomic number is more fundamental than atomic weight. So we consider only atomic number. So Mendeleev periodic table was not considered at all. Modern periodic table is considered and now it is used. So we use only the modern periodic table nowadays. So learn the definition of modern periodic law. There is a statement called modern periodic law and difference between Mendeleev periodic table and modern periodic table. Now next is classification of element in periodic table. Now how are elements classified in periodic table? They are classified by 4 ways. That is, first one is S block, second one is P block, third one is D block, fourth one is F block. So we consider only S and P block, S and P. So there are two big chapters called S and P block. If you see in your NCRT 11th standard textbook, even in 12th also. So this S and P has a special characteristic than other any elements. So where is S block located and what are its properties? So when you see a periodic table, the first two columns of a periodic table, from helium to radium, so that's called S block. So this is S block. So what is P block? P block is from 13. I didn't write 13, so 13 to 18. So consider this 13. From 13 to 18, including all the noble gases, they are called P block. So from your P block. So S and P. So in S, there are two things. What I said here is alkali metal and alkaline earth metal. So we are going to discuss about those both only. Now, what are the general characteristic of S block? So S block elements, general valency shell electronic configuration. Is NS1/2. Remember, NS1/2. So this elements contain only 1 to 2 of these electrons in outer shell. So group 1 NS1 is called alkali metal and NS2 is called alkaline earth metal. So next is their characteristics. So they are all reactive metal. First is they are all reactive metal. They have low ionization enthalpy. Low ionization enthalpy. So metallic character increases as we go down a group. Character increases. You have to mug up this stuff and all, because you can't guess it. You have to look close to the periodic table to understand this. Down the group. So next is P block. So P block elements belonging to group 13 to 18 are called P block. The valence shell configuration is valence electronic shell configuration is NS to NP126. So this is the electronic shell configuration of P block. So elements belonging to group 17 is called halogen. Now group 16 is called halogen. Remember this, both the terms. So they will ask you P block and S block. That's important. They won't ask much about D and F block. So next is periodic trends. Next is periodic trends. So in periodic trends, there are three important definitions. They will surely ask you. It will come for like 3 markers. So first one is, what is atomic radius? They will ask you. Atomic radius. So atomic radius is the distance from the center of nucleus to outermost shell. So next is covalent radius. So what is covalent radius? It is defined as 1/2 distance between the nuclei of two covalently bonded atoms, that is two covalent atoms. So next is metallic radius. So what is metallic radius? Metallic radius is half internuclear distance separating the metal cores in a metallic crystal. I think we need to mug up this thing because I don't know how to explain this one. So learn this 3 in this. Atomic radius is what? Atomic radius is distance from the center of the nucleus to outermost shell. That is called atomic radius. This question is asked for 2-3 times in boards and final exams. Covalent radius is half distance between a nuclei of two covalent bonded atoms. So these two questions are definite. Metallic radius most of the time it doesn't come, so don't waste your time learning this metallic, but remember this. Now cations and anions. What are cations? Cations are formed by loss of electron. An anion are formed by gain of electron. So example of cation is Li. It loses electron plus minus electron, and anion with plus E, it gains electron, so it becomes minus. So next important one is ionization enthalpy. Ionization enthalpy. So what is ionization enthalpy? The amount of energy required to remove an atom from gaseous atom in a ground state is called ionization enthalpy. Example, this is a gas molecule. So we are going to separate this gas molecule. We are going to remove an electron. So the amount of energy required to remove an electron from isolated gas molecule is known as ionization enthalpy. I'm writing a definition. The amount of energy required to remove an electron from an isolated atom in ground state. So this is called ionization enthalpy. So remember this term, ionization enthalpy. Next is electron gain enthalpy. Electron gain enthalpy. So what is electron gain enthalpy? So electron gain enthalpy is amount of energy released during addition of electron to a neutral gaseous atom to convert it into a negative ion. So amount of energy required while adding of electron to a gaseous atom to make it a negative. So in this ionization enthalpy, the amount of energy required to remove is called ionization enthalpy. In electron gain enthalpy, amount of energy required for adding electron to a gaseous atom is known as electron gain enthalpy. That's the difference. This is removing, this is adding. So this is addition, this is subtraction. Here when electron is removed, it becomes positive. Here when electron is added, it becomes negative. That is the only difference. So I write the definition. The amount of energy required during addition of electron to a neutral gaseous atom to convert it into a negative ion. So this is called electron gain enthalpy. Next is electronegativity. So what is electronegativity? Ability of electronegativity. So electronegativity is ability of atom in a covalent bond to attract a shared pair of electrons towards itself. So I write the definition. The ability of an atom in a covalent bond to attract shared pair of electron towards itself. So electronegativity is like a magnet. Okay, just remember, I'll teach you. Just to understand, I'll make you easier. So electronegative is like a magnet which attracts covalently bond shared pair of electron towards itself is known as electronegativity. So understand it. The ability of an atom in a covalent bond. So covalent is formed by what? Non-metals in a covalent bond atom to attract a shared pair of atom towards itself. So this covalent atom becomes a magnet and it attracts a shared pair of electron towards itself. So it attracts electrons. So this is all electrons towards itself. So they are called electronegativity. So which has more electronegativity is fluorine. Don't remember this. This is asked most of the time in NCRT. Fluorine is more electronegative element. So in periodic table, fluorine is the most electronegative because it has large shell and electronic configuration is more in fluorine. So that's why it is more electronegative. So till here, this is a main portion for supplementary examination. Just learn what are the law of octave, law of threads, then Mendeleev law, then what modern periodic law, then the scientist's name who discovered what, then how many rows and columns, what is S block and P block, then the general characteristic, then what are the three, what is atomic radius, covalent radius, then what is electronegativity, electron gain enthalpy, then ionization enthalpy. Just learn the terms in this lesson. Only terms. I am saying only terms in this lesson because terms are important in this lesson. So learn the terms and don't break your head mugging up all other stuff. So learn the terms and some give reason questions. That's it.